This second problem is also a particle equilibrium problem. You notice point D is right there and all the forces are going through there. Not to mention that the title of the problem says 3D particle equilibrium. Anyway, the free body diagram for a particle, again, is just a point. There's point D. And in a 3D problem, I draw all the forces pulling away. So you can see that I've drawn all these forces pulling away. Not to mention, these are all ropes, so they have to be pulling away. Now, I drew this over the existing picture so you can see what I'm doing. When you do it on a test, you're just going to do something like that. So there's point D, you've got the bucket coming down, that rope going to the left, this rope coming up like this, and that rope going up there. And just label the forces so I can tell what they are. That 100-pound bucket, maybe you're just going to call this T going to B, T going to A, and T going to C. Since I typeset this, or I made this all pretty, I was very formal and I wrote F, D to B, F, D to A, etc. But this is good enough for the test. In the 3D particle equilibrium, what we're going to do is write all the forces as vectors, and then we're just going to collect all the x components, the i's, all the y components, the j's, and all the z components, the k's. The first step to writing any force as a vector is to get the unit vector. So the bucket is obviously going down into the z direction, so its unit vector is minus k. The force pointing from D to B is going in the y direction if you look at the picture, but it's going in negative y direction, so negative j. The force going from D to A and a force going from D to C is a little more complicated. They're a little more complicated, so we need to get the unit vectors more formally. What you do is you get the R from D to A, the position vectors. So remember, you start at D and you walk to A, and that's what I got. I just looked at the picture that to get to A from D, I would have to walk 3 in the X, minus 1.5 in the Y, and up 3 in the Z. That's the position vector, but its length is not 1. It's not a unit vector. In fact, its length is exactly 4.5. This is one of those nice 6, 3, 7 3D vectors that has a length of 9, but it's all divided by 2. And so to change that 3i minus 1.5j plus 3k into a unit vector, to have it a length of 1, you divide by the length right there. You do the same thing for the D to C vector. It's going from D to C. You have to do that, minus 1.5x plus 1y plus 3z. And its length is 3.5. And again, to turn this position vector into unit vector, you have to divide by the length. And there you go. And so now all I do is I take all the x components, all the y components, and all the z components. So FDA, the dA vector, has a x component of 3 over 4.5 times FDA. The DC vector has a x component. If you look here, it's just this minus 1.5 divided by 3.5. And those are the only x components because FDB has only a y and the bucket has only a z. Okay, let's add up all the y components. FDB, I just said, was all in the negative y, so there you go. And the y component of FDA is minus 1.5 over 4.5. And the y component of FDC is 1 over 3.5, just looking at the unit vectors, times FDC and times FDA. Finally, in the z direction, we do have the bucket. It's going down with 100. And then FDB, again, only has a y component. It doesn't have z. So FDA has a y component of 3 over 4.5. And FDC has a y component of 3 over 3.5. Here are your 3 equations, and here are your 3 unknowns, FDB, FDA, and FDC. I've written out the 3 equations here a little more cleanly. and I included the equations that didn't have FDB. I just went ahead and put 0 in there because that lets me do this more easily to type into my calculator. These were all the FDB coefficients, FDA coefficients, and FDC coefficients. And on the right hand side, I had 0, 0, 100 for equation 1, equation 2, and equation 3. I carefully plugged in those 9 numbers into my calculator, pressed solve, and this is what came out. I highly recommend that you learn how to use your calculator. This wasn't that bad. If you had to do it by hand, you could have solved these two first. Solve those for FDA and FDC. Those are 2 equations of 2 unknowns. You could have done that, and then after you solve that, plug back into the 3rd equation for FDB. So this one was not too bad. You could have done it by hand, but it is certainly more convenient if you know how to use your calculator to solve this.